Welcome to class once again. Today we'll talk about the cardinality and the power of sets. So let's talk about the cardinality and the power of sets. So having discussed some types of set notations in our previous lectures, we'll move a step further by introducing other set notations. Consider we have a set C below. So let's say we have set C here, which contains the following elements: A, B, C, D, and E. This set is said to have a cardinality of 5. How is this possible? Because the number of elements in this particular set is 5. So by counting, we have 1, 2, 3, 4, and 5. So by implication, the number of elements in a given set is called the cardinality of that particular set. So the cardinality of a set simply is the number of elements in a particular set. Considering the set C above also, so we have set C, the cardinality is denoted by n of C, that is the number of elements in C. Is that understood? Okay, for instance, let's take an example. If we have a set P, if you have set P, which is equal to the multiples of 3 less than or equal to 20. So by counting, we have 3, 6, 9, 12, 15, and 18. These are the elements contained in this particular set P, which forms the multiples of 3 less than or equal to 20. So we are asked to find the cardinality of this set P. Like I said earlier, the cardinality is seen as n of P is equal to, all you just need to do is to count the number of elements in the particular set. So by counting, we have 1, 2, 3, 4, 5, and 6. So the cardinality of the set is 6. So from our knowledge of what cardinality is, that is the number of elements in the particular set, we can now deduce that the cardinality of the set P is equal to 6. Since this foundation has been made, let us talk about the power of a set. So what then is the power of a set? So power is the next thing we are going to consider now. The power of a set. From our physics, we know that power is the ability to do work. So the power of a set is that set that contains all possible subsets of the sets that can be obtained. I'll take that again. The power of a set is that particular set that contains all possible subsets of a set that can be obtained. And by now, I'm sure you know what subsets are. From our previous lessons, we talked about subsets, which are the sets obtained from other bigger sets. So the power of a set is denoted by this symbol, P of X. So whenever you see something like this, it shows the power of the particular set. So if the cardinality of the set is n, let's say the cardinality, you know what cardinality is, that is the number of elements contained in a particular set. So if the cardinality of a set is equal to is n, so let's say n is the cardinality. So let's say n is the cardinality. Therefore, the power of the set P, let's take P as the set we are considering. So the power of the set P is equal to n into P of X, where X signifies the elements in set P. This power of a set, which is denoted by n equals P of x, is equal to 2 raised to the power of n. And like I said earlier, n is the cardinality of the set. So this simply implies that the number of possible subsets of a particular set with the cardinality of n is 2 raised to the power of n. That being said, let us consider a set as an example. So consider the set Q, which is equal to the following elements: A, B, and C. So these are the elements in the set Q. The first thing we have to note is the cardinality of this particular set. So the cardinality of the set Q, which is seen as n, is equal to 3, because the number of elements by counting is 3. So if the cardinality of the set Q is 3, therefore the power of this particular set is equal to the power, which is seen as P of x, is equal to 2 raised to the power of n, which is equal to 2 raised to the power, and this gives us 8. It then shows that the number or the possible subsets of this particular set Q is equal to 8. How can we get this done? So let's list the possible subsets of this particular set to check if they will be up to 8 in number. You agree with me that A is a possible subset of this set Q. You also agree with me that B is a subset of set Q. C is also a subset. A and B are both subsets of this particular set because A and B can be found in the bigger set Q. You also agree with me that B and C are possible subsets of set Q. And A and C could also be seen as a possible subset. We can also have A, B, C, because we said every set from our previous lecture on subset, we said every set is a subset of itself. And finally, you should also know that an empty set, this is called an empty set. An empty set is a subset of every other set. So with this, we've come to the end of this lecture on the cardinality and the power of sets. Other aspects of the subject matter will be discussed in our subsequent classes. I'm sure you have some questions for me. Kindly drop them in the comment box as prompt answers will be supplied to them. Always know this for sure, that you can always do better. Be better. See you in our next class.